Alright, so first let's try to derive an expression for how high the nth bounce is. So just to review a bit, our first bounce, right, we're going to drop it from 100 meters, it's going to go down to the ground, and then it's going to come up 0.7 of the way, 70% of the way. In this case, that'll be 70 meters, right? Then it'll go down again, and it'll bounce up 70% of that way. So that'll be, of course, 70 times 0.7, and so that'll be 49 meters that it'll bounce back up. Then it'll go down again. Just write the meters. It'll go down again, and then it'll bounce up, and you can keep calculating this by just multiplying by 0.7, and you could just brute force it, just keep multiplying by 0.7 until you got under 1 meter, but that would take a while. Let's do it mathematically. So if we look at these numbers, right, we know that the initial bounce, we're starting with the 0th bounce in a certain sense, has a height of 100, right? And then to get to every successive bounce, we need to multiply by 0.7 that many times. The first bounce, we're only multiplying by 0.7 one time. The second bounce, we're multiplying by 0.7 twice. We're multiplying one time to get to the first bounce, and then one time to get to the second bounce. And the third one, we'll be multiplying by 3 times, and etc. So you can pretty quickly derive the expression 100 times 0.7 to the n power. Okay? So this is going to be equal to nth bounce height. Okay, so let's think about this now. How do we figure this out? Well, what if we just set this equal to 1, right? That'll give us an equation that we can now solve for n as our only unknown. And this is basically saying let's set the nth bounce height to 1 and find out what n is. So we now have this nice equation and we can solve it fairly simply. So we can divide both sides by 100. We get 0.7 to the n equals 1 over 100. Now we can take the logarithm. Remember, if we have an exponent we're solving for, we want to take the logarithm of the base of the exponent. So let's take the logarithm base 0.7, which is a bit weird, but 0.7 to the n equals log base 0.7 of 1 over 100. Now, this all cancels out and becomes n, because that's how logarithms work. And so n is just equal to this over here. And you can punch this into any calculator, and you'll get that n is equal to 12.91. Now, we're not quite done, because obviously there isn't a 12.91th bounce. That's a fraction, right? So what we need here is we need to figure out which way we round. If we think about it, what this means is that the 12th bounce will be slightly more than 1, right? Because it hasn't quite reached the 12.91th bounce yet. And the 13th bounce will be slightly less than 1. And so it seems pretty obvious that we should just round up to the 13th bounce. Now, even if n ended up being 12.01, this would still be true, because the 12th bounce would still not quite be 1 meter. But anyways, if we plug this in, we get that the 13th bounce is like 0.969 meters, and so it's slightly below 1, and the 12th bounce is a decent bit more than that. So the 13th bounce is the first bounce below 1 meter.